Hi, so in this video we're going to use the substitution rule to evaluate a definite integral. So we have a integral with limits, bounds from 1 to 3. So we have the substitution rule up here. I'm going to write my u, we call it usually the u-Substitution. So in this example, I have my u to be, of course, I'm going to have my u to be the inside of the square root. So my u is going to be 2x squared plus 5. So to complete this, I get the du to be 4x dx. And the way I like to think about this is I have the dx here with that x. So for that part in my du thing, so my x dx is 1/4 of du. Okay, so we're going to use that. And then I'm going to evaluate this integral. So what I'm going to do is evaluate this as I'm going to have two methods. So first, I'm going to have method 1, which I'm going to change the limits of integration, because I want to write this now in terms of u. The x dx, of course, is 1/4 of du, right? And then here I have, I'm going to write this like u to the 1/2, correct? But then I need to change my limits of integration because now my variable is u. So if I write this, it becomes, I need to check when x was 1, so go over here. So when x is 1, the u becomes 2 times 1 squared plus 5, so that's a 7. Okay? And then when x is 3, the upper bound, I found a u when x is 3, which is 2 times 9 plus 5, so that's a 23. Okay? So my method 1 is going to be changing the limits of integration. And then from here, I can just go forward, right? So this integral becomes, can write the 1/4 outside. It's going to be u to the 1/2 plus 1 becomes 3/2. I'm dividing by 3/2 now, so it's the same as multiplying by 2/3. Let me write 2 steps. I'm dividing by 3/2. And then I'm evaluating this from 7 to 23. So this becomes 1/4. The reciprocal of 3/2 is 2/3. And I'm going to write this like u to the 3/2 evaluated from 7 to 23. So this becomes, I can simplify this to 1/6. And I get 23 to the 3/2. I can put a factor of 1/6 into 23 minus 7 to the 3/2. Okay? That's my method 1. So the method 2 is not that much different. It's just that sometimes we don't want to bother with what I did here about changing the limits of integration. Let me keep this on the side. For my method 2, I'm not going to bother changing my method of integration. Changing my limits of integration. I'm going to write from 1 to 3. I'm not going to write. I'm going to forget for a minute that I had a definite integral and treat this as an indefinite integral. So I have my x square root of 2x squared plus 5 dx. And I'm not going to write any limits of integration. And this just becomes, using the same u-Substitution, of course, it's the same thing. I'm going to have 1, I'm going to write the integral of 1/4, I can write outside, of u to the 1/2 du. I'm copying it from here without the limit of integration. And this just becomes 1/4, because it's exactly the same thing, times u to the 3/2. I'm going to skip the step now and multiply by 2/3 and evaluate it from 7. The original, I'm not evaluating anything, let me give it like that. And now this is 1/6 of u to the 3 halves. But now I go back to the u. Who was the u? Well, it was 2x squared plus 5 to the 3 halves. Okay? This is like a regular indefinite integral where I don't have any limits of iteration, and I go back to my original. The important thing here is that I go back to my original variable axis. Okay? But now, if I say, okay, this is what the answer of this gives me. But if I want to solve it as an indefinite integral, as a definite integral, now I go back and say, okay, so now what I do have is this integral from 1 to 3 that I wanted to find. I know the answer is this. And now I evaluate at the original limits, right? Which is the same thing, because what you're going to be doing is right here, you're going to plug in x equals 3, so I get 2 times 9, 18 plus 523 to the 3 halves, minus when I plug in a 1, it's 2 times 1 plus 5, 7 to the 3 halves. So of course I got the same answer. Sometimes it's easier to change the limits of iteration. Sometimes it's easier to not bother with that and plug in the original limits. This is an example where it is as easy or difficult to do either way. But in some examples, it might make sense to keep the original limits, and we prefer sometimes this one. And sometimes we don't have to do it and just prefer that one. Okay.